Okay, all we want to do today is deal with a little bit more inequalities. And all we're trying to do is, like we did with the equations got a little bit more complex each time. The inequalities can do the exact same thing. This is all stuff that we already know how to do and we can do. So we're just dealing with inequalities. So it's going to be a quick lesson, and then you guys will be off to trying to apply it on your homework. All right, so number one, remember when multiplying. When multiplying, and again, if you want to underneath, you can say dividing. But multiplying by the reciprocal and dividing are the same thing, but anyhow. Remember when multiplying both sides by a negative quantity, don't forget you have to flip out, right? So remember to reverse or flip or whatever you want to say the inequality symbol. Again, guys, just be careful here because it's a shame you go through all that you have to go through to solve an inequality, and it has a negative, and you multiply by a negative or you divide by a negative, and you don't reverse the symbol, and what a shame. Or again, you people that flip out all over the place and you're flipping everything. Again, what a shame because it's something you can do, something you can get correct, and you mess up on the symbol. By the way, one other thing to be very careful about is make sure your answer has an inequality symbol in the blank, not an equal sign. That's the other thing. All right, so you know how to do this stuff. So you look at A, and the only difference is you're going to add like terms before you solve. Piece of cake, right? So everybody looks at the ends and says, when we add up the ends on the left, we get Earth to daydreamers, Earth to people. Got to be thinking, right? Got to be thinking. If you don't think in this class, that's half your problem. If you're just sitting back in neutral, waiting to write something down, hence your problems. You have to be thinking. You have to be thinking. You have to be thinking. Right? We just add up the 5n and the negative 9n. It's a negative 4n piece of cake. So, class, what would you do next? Just say it. Okay, so I'm going to add a negative 3 to both sides. Hey, does it matter that some people said subtract 3 and I always say add a negative 3? Does that matter? Does it matter math-wise? Mathematically, won't matter one bit. The answer will be the same either way, right? If you do everything correct. Is there a mental aspect of it, though? And the answer is yes. So again, look, if you're saying subtract 3 from both sides, I'm not sure you're really understanding a very simplistic aspect. And that's things added to the variable. You add their opposite to both sides. Again, maybe you do and you're just saying it wrong, but I wonder. And it's little things like that that cause problems later on. So hopefully you all agree a negative 4n is less than 16. Go ahead and finish it off. Finish it off. Kill it off. And everybody flipped the symbol, right? And you got n greater than negative 4 because a positive divided by a negative is a negative. How many got that correct? Okay. All right, so that's pretty simplistic. Now look at B. Haha, B has what I like. Negation. Yeah. How would you approach this problem? Somebody raise their hand and tell me how you would approach this problem. Andrew? Okay. So Andrew's going to get rid of the negation right off the bat. I think that's the best way to approach the problem. Get rid of the negation right away, and therefore then you're dealing with a regular inequality. And so he said reverse the symbol, and because it didn't have a line, he said to put a line under it, and that's correct, right? Remember, to unnegate something, is that such a word? Probably not. All right, all you English buff, this is math, so we can get rid of it. No English police out there. Yeah, to get rid of the negation, you're going to flip the symbol. If it's already equal to, then it's not going to be. If it's not already equal to, then it's going to be. All right, and now at this point, you look at this problem, and you should be able to finish that. So let's go ahead and we'll do a little bit of it together. Left side's going to stay the same, right? On the right-hand side, we're going to distribute. Let's see. Alexis, can you distribute that for me? What do we get on the right side? How many agree? 8 minus 4x, right? And that's the distribution of that. Okay, so you look at the problem right now. What would you do next? Somebody raise their hand. What's next? Josh, what would you do next? Yeah, so Josh is thinking, hey, I have variables on both sides. At my first opportunity, I want to get all my variables on one side. By the way, I will tell you this. If you guys remember, my general MO, modus operandi, is I want to move the variable to the side that will make them positive, right? That's my normal MO. I don't do that with inequalities. With inequalities, I always move the variable to the left. Because again, our brain understands an inequality so much better when the variable's on the left. And so I always move them to the left. I just always do. I think it's wiser. It's not that you have to. I think it's wiser. All right, so hopefully you agree we end up with 7x minus 7 greater than or equal to 8. We're going to add a positive 7 to both sides. And so your next line is going to be 7x greater than or equal to 15. Uh-oh, I did a step in my head. Hey, we should be getting to the point where we can start doing a few steps in our heads, but just be careful. If your head won't get you the correct answer 49 times out of 50 doing that in your head, Byron, you're daydreaming. That's why I called your name. If your head won't allow you to get that right 49 times out of 50, then write the step. Same thing here. A shortcut is simply dividing the other side by the 7, right? Because you're going to divide both sides by the 7. But again, if your brain won't get that correct every time, 49 out of 50, then do divide both sides by 7, right? X greater than or equal to 15 sevenths. We're going to leave it as mixed now, or as an improper fraction. Yes, we're going to leave it as an improper fraction. Right? If you were graphing that, what would you do? They told you to graph this. What are you going to do? Say, I don't know. Raquel. Mixed number, right? Just turn it into a mixed number. 2 and 1/7. You know where that is. You know where that is. A little bit past 2, right? 2 and 1/7. A little bit past 2. Not a problem. Okay, look at C. C's got negation again. It's got some distributing. Why don't you guys try that one? I'm going to pause the video. Right is right. Is the rest right? I don't know. All right, on 3, give me the answer. Nice and loud. Going to say y greater than. Here we go. 1, 2, 3. Okay, hopefully you were going to get y greater than 2/3 because you're going to reduce the 6/9, right? Don't lose that little point at the end for not reducing. And you should have gotten 6/9. Be careful on your distributing. Let me back up a little for you guys. Pitfall number 1. Remember, you cannot do 6 minus 3 and get 3. Why can't you do that? Somebody raise your hand and explain why we can't do that. Andrew? Exactly, right? So you're violating what? The order of operations. So you can't do 6 minus 3 first. You got to distribute the -3. That's what's got to happen first. Distribute that out. And then again, just be careful from there on out. You got a -6 on the left, add a +6 both sides. Divide both sides by -9, reversing the symbol. And reduce, and voila, you are there. Let's take a look at this. Let's take a look at D. Oh no, fractions. Okay, so you come across this fraction problem. What are you going to do? Now you can solve it. I will say this. You can solve it conventionally, dealing with the fractions, or you can use the methodology of getting rid of the fractions. Most students do better when they get rid of the fractions. And by the way, the more fractions you have, the better it is to get rid of the fractions. So let's solve it by getting rid of the fractions. So who remembers what to do to get rid of the fractions? All right, I'm looking for somebody that hasn't contributed yet today. Come on. What do you do? How many, let me see your hands. How many of you have a thought in your mind to get rid of the fractions? Let me see your hands. Okay, that's a bit of a problem because this is a concept we've already learned. This is something we've done already in how to get rid of the fractions. Ileana, your hand was up. What would we do to get rid of the fractions? We got to multiply every term by the LCD. That's the methodology for getting rid of the fractions. So you're looking at the denominators. When you have a 2, a 6, and an 8, what would be the LCD? Say it if you know it. Not 18. 24, right? Because the 8 doesn't work for 18. 24 would be the LCD. So I have to multiply the first term by 24. And the second term by 24. And the third term by 24, right? And look, the whole purpose of this was to get rid of the fractions. That means every denominator will divide into it. Every denominator is going to divide into what you have. That's the whole purpose of it, to get rid of the fractions. So let's see where we're at. Front term is a negative 36a. Hopefully you concur, if I can write it. Negative 36a. Second term is a positive 20. You have a less than, and it's a negative 3. Easy problem now, right? You know, so again here we're going to add a negative 20 to the right-hand side, right? Negative 20 to both. So we're at negative 36a less than negative 23. Yuck. And we're going to divide both sides by a negative 36. And again, whenever I do that, I immediately reverse my inequality symbol because I divided both sides by a negative. And this thing's prime, isn't it? 23 is a prime number. So 23 36. X greater than 23 over 26. Doable? Okay, so look, everybody's memory's been refreshed now, right, on how we get rid of fractions. We've done problems like this already. See, this is the thing about math, and this is why you need to be reviewing your math as we go. Each chapter, you should be reviewing the stuff of that chapter. Because, again, it'll come up again. We'll use it again. All right, well, there's the refreshing of your memory. Hopefully you'll remember now. All right, let's deal with the word problem. Find the greatest 3 consecutive odd integers such that the sum of the first and the third is less than 84. Now, I helped you out. I put the NTV. Some of you won't NTV, and you'll stare at the problem for 40 minutes, which is ridiculous. Okay? And you shouldn't be staring at a problem for 40 minutes. Okay? You should write the original. You should try to do something, and you should move on. If it's an odd, you should try it twice and move on, and I'll go over it in class. If you're staring at a problem for 40 minutes, that's your problem. I didn't give you that much homework. You made it that long. I'm just telling you. If you're staring at a problem for 20 minutes, you're staring at it too long. I'm just telling you. That's not the homework I gave you. You made it that way. So, but how do we NTV? Somebody help me out. We've done this already as well. This is review. How are we going to name the variable? 3 consecutive odd numbers. Man, you got all the answers today. Brain is firing on all cylinders. Come on, somebody else. How are we going to NTV? This is review. Pamela, go ahead. All right, hold on. And therefore, I see where she's going. She's going to tell me the second number, and she's going to tell me the third number. So let me pause for a second. She knows where she's going. Jog your memory. We have 3 consecutive odd integers. The first one is n. Pamela, second one is? Yes. Thank you. Almost looked at it wrong myself. 3 consecutive odds. And the third one is n plus 4. You know, we did this earlier. The first number's 3. What's the next number? 5. 2 more than the first, right? 3, 5, 7. From a 3 to a 7 is the first plus 4, right? This is a set pattern. This is set. This never changes. Never, 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 never. 3 consecutive odd integers are always n plus 2, n plus 4. 3 consecutive even integers are always n plus 2, n plus 4. 3 consecutive integers are always n plus 1, n plus 2. Always, 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 always. Can we get a second grader to memorize that? Yes or no? Yes. Now, they may not know what to do with it, but they can memorize that, right? So you can too, so you have to, so you don't miss it. All right, because you don't want to miss problems like this. Okay. Somebody tell me what to do next with this inequality now. Tell me what to do. Remember, we're looking for key phrase. Let's deal with the, if it were an equation, we deal with the equal sign. It's an inequality. Let's deal with the inequality sign. So somebody tell me what the inequality sign is. Sam? All right, and how does the arrow go, Sam? Arrowhead points to the left, and I agree. No line underneath because it's not less than or equal to. And everybody would agree to put the 84 on the right-hand side, right? Okay. Now we got to do the other part. And the other part says the sum. And everybody knows the sum is. And what are we adding up? So what would you add up? First and the third. So the first is, and the third is, that's it, people. N plus 4 is less than 84. 2n plus 4 is less than 84. 2n is less than 80, right? Add a negative 4 to both sides. Do you concur? And therefore, n is less than, say it, 40. Now I have a big word of advice. I'm going to give you 3 letters right now. What letters am I going to give you? Yes. Whoa. Let me get N in there. Oh, it's my pen. I forgot on an erasable ink. Yeah, ATQ. Thank you. Whoa. The magic pen is magical. Answer the question, right? So we got to be careful right now that we finish off by answering the question. It says find the greatest 3 consecutive odd integers. There's a lot of odd integers where the sum of the first and the third is less than 84. For example, is 1 an odd integer? Is 5 an odd integer? Is the sum of them less than 84? Yes. Would those be part of the answer technically? Yes, except it says we want the biggest ones. We want the biggest numbers where the first and the third is less than 84. So n has to be less than 40. So what can n equal? 39. We're dealing with odd numbers. See, that uses, it's a little bit of brain thinking there. You do have to think through that. The question's about odd integers. So if we got to go less than 40, what's an odd integer less than 40? 39. Ah. Now, did we still answer the question? No. It says find the 3 greatest consecutive odd integers. So the first number is 39. The second number is? The first number is 39. The second number is? 41. N plus 2. Isn't the second number n plus 2? Right? What's the third number? 43. The 39 plus 4. And in case you don't think it works, let's check it out. Let's take the first number, 39, and let's add the third, 43. 39 and 43 is what? 82, and 82 is less than 84. It worked. Remarkable. All right. I know that's a little off the wall, but hopefully your memory's refreshed. You'll get a couple word problems with all the rest. So there's your work. And so, homework tonight.